Welcome to the second video for section 4.4. In this video, we are going to learn how to solve log equations. To recognize a log equation, you will see a log term in the equation that contains a variable. So these are very easy to recognize. And we are going to learn two methods for solving log equations. Which method we use depends on whether the equations contain log terms and constants or only log terms. Remember, a constant is just a number, like 5, for example. So if some of the terms in the equations are just numbers, then we are going to use the method that you see on this slide. So you have some log terms and some constants in the equation. Step 1, evaluate any log expression if possible. So that uses the properties that we have been working on in this unit. Step 2, use algebra and log properties to write one side as a single log whose coefficient is 1 and the other as a constant. So once you complete step 2, it's going to look like this. On one side you'll have your log term with a 1 in front, and on the other side you'll have just a number. Sometimes you may have to condense to get it into that form. So the log properties are really important in solving these. So it's good if you have practiced those prior to trying this lesson. Step 3, rewrite the equation in exponential form. And that is something that we worked on at the beginning of Unit 4. So this, after you complete step 2, it's in log form. You're going to convert that to exponential form. And that will get rid of the log out of the equation so that you can then solve for the variable. Now, one thing you do have to do on these log equations is check. You check solutions in the original equation and make sure that when you substitute it in, you are not trying to take the log of a negative number. Remember, we cannot do that. When you go back and look at the graph and see the domain, then it makes sense that, okay, the log graph doesn't allow any negative numbers in the domain. So we'll keep that in mind as we solve these equations. Instructions say, solve each log equation, reject values not in the domain, and give the exact answer. And by exact answer, that just means you don't have to turn it into a decimal, just leave it in its exact form. Okay, so look at number 1. The first step said to evaluate any logs if possible. So here we have log of 2x. We cannot evaluate that. The second step, we want a single log, which we do have, with a 1 in front. We don't have the 1 in front, so what we need to do is divide by that 6. That 6 is being multiplied to the log, and so if we divide by it, 6 divided by 6 is 1, so now we just have log of 2x, and on the right side we also divide by 6. And now step 2 is complete because we have a single log with a 1 in front. We have a constant on the other side of the equal sign. So step 3 says, okay, convert this log form to exponential form. So in another color, I'm going to stick in that form in general is x equals b to the y. So that's the step that we're at. We want it in this form. So look back at your log equation. Remember, it's log of x. So whatever you're taking the log of, that is the x. So we're going to put 2x in place of x. If it is ln, there is an invisible e there. So that's your base. E is equal to the base. And whatever number's on this side, that's y. Remember, it's log of x equals y. So y is 5. And that's how we convert it to exponential form. Next, we are ready to solve the equation for x. So all we have to do here is divide by 2. That gets our x by itself. And because we're not going to give any decimals, then that's it. It's just going to be e to the 5th divided by 2. Now, once you get your answer for x, you are going to plug it back into your original. You do not have to totally work it out. You just have to make sure that you are not taking the log of a negative number. So we are doing, so here's our check. And you don't even have to write it out. A lot of times you could do it in your head, but I want to kind of show you what I'm doing. We had log of 2x in our original. So if we put e to the 5th over 2 in place of x, and we could divide those 2's out, we'd be doing log of e to the 5th. Well, e is a positive number. It's 2.72 rounded, and to the 5th power, of course, it would still be positive. That's all you have to make sure is that I'm taking the log of a positive number. And then we can say, okay, this is good. I'm going to box it in, put a check mark. That means I did go through the process of thinking about what's going to happen when I plug that back in for x. Okay, so now we've seen one example. Let's keep going, and the more we do, the more you'll get the hang of it. Number 2, we cannot evaluate this log. We already have a single log with a 1 in front and a constant on the other side. So basically steps 1 and 2 are done already. So we are ready for step 3, which is the exponential form. X equals b to the y. So in our log form, it's log of x. So this square root of x plus 4 is going in place of the x. We have an ln again, so our base is e. And y is this constant that's by itself over here, which is just 1. And of course, e to the 1st power is just e, so you don't even have to write the 1. Okay, we are ready to solve that equation. It is a radical equation. It's been a while since we've solved those. You have to have the radical isolated, which it is. And if it's a square root, you are going to square both sides. And that will get the radical off. So then we just have an x plus 4. On the right side, if you have an exponent to another exponent, you multiply those. So it'll just be e squared. And now we can isolate the x by subtracting the 4. And we're going to leave it in that form. I can't actually subtract those, and I don't want a decimal. So we're going to leave it as e squared minus 4. But then we need to think about checking. So I'm going to do log of the square root. Now in place of this x, I'm putting this whole thing, e squared minus 4. All of that goes where x is. Then I still have a plus 4 under the radical. So if I combine like terms, negative 4 plus 4 is 0, then I just have an e squared there. And if I square root e squared, I get e. E is a positive number, so then we're good, as long as that number's positive. So we're going to box this in and put a check mark. Okay, so we've done 2 examples now where we had ln, meaning that the base was e. Let's keep going and try some other examples. Okay, remember step 1 said, if you can evaluate any logs, go ahead and do that. So when you have log of a variable, you can never evaluate it. But here's a term that's log of a number. So then I would want to be thinking about, could I write 4 as 2 to a power? We'll do that over here on the side. We could write 4 as 2 squared. Now that these are the same, the whole thing is equal to the exponent, which is 2, by property 3. So let's go back to our equation here and replace that log term, that log base 2 of 4, that whole thing is equal to just 2. 2. And then I can go ahead and do 5 minus 2. So on the right side I have 3. And now we're ready for step 2 that said, okay, we need a single log, which we do now have, with a 1 in front, which we don't have. So to get the 1 in front, we're going to divide by 3 on both sides. So on the right side, 3 divided by 3 is 1. Okay, step 3. Convert this log form to exponential form. Go ahead and see if you can do that step on your own. I'll give you just a second. Okay, so in place of x, you should have x minus 1. In place of b, that's your little subscript number, you should have a 2. And y is 1. So since the exponent is 1, you can write it or not write it. It's the same thing as just a 2. And then you're ready to solve. Just add 1 to both sides and we get x equals 3. So to check it, there's only one x here in our original equation. And if we put a 3 there, so we'd have log base 2 of 3 minus 1. That's log base 2 of 2. There 2 is a positive number, so then we can keep this answer. Okay. Let's look at another one. One more using this method. And the first thing you probably notice about number 4, it has a lot of log terms in it. And they all have a variable, log of an x. So I cannot evaluate any of the logs. But I need to get just one single log in the equation. And this is where the condensing comes in. So remember, when you have addition, you're going to condense with multiplication. That was property 5. We'll use that first. And so let's go ahead and condense these first 2 logs together. So it'll be log, keep the base of 2, and then you're going to multiply the x times the x minus 3. So I'm going to go ahead and distribute that. It'll be x squared minus 3x. So we're just starting with these 2. We're condensing those down to 1 log. Let's just bring down everything else to the next step. And now we need to condense again, and this time we have a minus sign. So that's property 6. This says, okay, when it's minus, you can make it one single log, still the same base. And this first part goes on top and the second on bottom. So it'd be x squared minus 3x over x plus 2. Log of that whole fraction. And the right side is still just 2. So now I have a single log with a 1 in front, constant on the other side. That means we are ready to convert it to exponential form. So this whole big fraction here is our x. The base is 2, that little 2 that you see. And then y is also 2, so it's 2 squared. So let's go ahead and evaluate 2 squared, which is 4. Now we need to solve this equation. This is a rational equation because it has a fraction with a variable in the denominator. And the way we solve those is to clear out the fraction by multiplying by the LCD. And so x plus 2 is our only denominator. That's what we're going to multiply by. So on the left, we can divide those out. And I'm going to move over here to finish up. So now I've got x squared minus 3x. And on the right, let's go ahead and distribute the 4x plus 8. So this is a quadratic equation because it has an x squared in it. So I need to set it equal to 0. I want the x squared to stay positive. So we'll keep the x squared minus 3x on the left. Let's subtract the 4x and subtract the 8 to get 0 on the right side. And then we'll go ahead and combine like terms. And let's try to solve by factoring. If we could not factor it, we could complete the square or use the quadratic formula. But this one actually will factor. We need factors of 8 that subtract to be 7, which are 1 and 8. Different signs, larger negative, so a negative 8 and a positive 1. Set each of those equal to 0, and you'll get x equals negative 1 and x equals 8. Okay, now before we box them in, we need to think about what's going to happen when I plug those back in for x in my original equation. Let's start with the negative 1. I'm going to put it in red here. So if I come back, now I've got lots of x's in here, so I'm just going to start with my first one. If I put a negative 1 in place of this x, now I've got negative 1 minus 3, which is a negative 4. And I cannot take the log of negative 4. Therefore, I'm not going to use the negative 1. Just put a mark through it. Now, we just make sure you understand we are not marking it out because it is negative. We are marking it out because when we substitute it, we end up taking the log of a negative number. If this had been a plus 3 instead of a minus 3, then it would have been okay right there. Now, as soon as you come to one log of a variable that causes it to be a negative, then you can stop and mark it out. You don't have to check all of them. So we move on to 8. And if I put 8 in for x, 8 minus 3 is positive. And then we come to our next x and we put the 8 in. That's positive. And then we come over here and we do 8 plus 2, and that's positive. So it is positive in all of them. So as long as it's positive, you have to keep checking until you get to the end. But it works in all of them, so x equals 8 is our solution. Okay, so remember, before we started these 4 examples, we were saying that, okay, the steps that we're using here are going to be used when you have log terms and a constant. Okay, let's look at all of those. So here we've got log, 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 constant. I'm going to circle the constants. And now let's go back to number 3. Log term, constant log term. And let's look back at number 1 and 2. Log term, constant. Log term, constant. Okay? So those steps that we just did, you're going to use when you have a log term or more than one and a constant. But some log equations have only log terms, no constants. In that case, you're going to follow different steps, and actually these are probably easier than the first kind. Step 1, use log properties to write each side as a single log whose coefficient is 1. So you're going to have a log on the left side, a log on the right side. They both need to have 1s in front. Then you can use the 1-to-1 property. So if log of m equals log of n, then we know m must equal n. And we can just set this equal to this and solve. And we still have to check as far as taking the log of a negative number. So let's try it. Okay, so first step, we need a single log on each side, which we do have, but we need a 1 in front. So on this left side, a couple of ways you might think about it is, well, let me divide by 2, but if I divide by 2, 2 is not going to divide evenly into log of 49, so then basically I'd have 1/2 log 49. so I still wouldn't have a 1 in front. So the other option is to make that 2 an exponent. That's property 7. So let's rewrite the left side as log of x squared. And now I've got a 1 in front of each log. So the next step is to use the one-to-one property. If log of m equals log of n, then m, this is our m, must equal n. So basically you're just dropping the logs off and you're going to set x squared equal to 49 and solve that equation. It's a quadratic equation. It doesn't have an x term, which means we can solve by the square root method. So if I square root both sides, on the right side it's plus or minus square root of 49, which is a perfect square. So it'll be plus or minus 7. I'm going to go ahead and separate those. 7 and negative 7. Because we need to check each one separately. So let's start with the 7. If I put 7 back in here for x, certainly log of 7, we're taking the log of a positive number. So that's good. But if I put negative 7 in there, I can't take log of negative 7. So we're going to mark that one out. So only answer is positive 7. Okay, number 2. So remember we need a single log on each side. We've got that over here on the right side. To get a single log on the left side, we're going to have to condense. Since we have addition, we condense with multiplication. It's property 5 that we're using. So we make this 1 log, still base 2, and we're going to multiply x plus 3 times x minus 2. So I'm going to go ahead and FOIL those. First, x times x is x squared. Outside negative 2x, inside positive 3x. So combine those is going to be a positive 1x. And last, minus 6. Keep the right side as it is. And now I have a single log on both sides with 1's in front. So next step, set m equal to n. This is your m. This is your n. Just take the logs off. X squared plus x minus 6 has to equal 14 for these sides to be equal. So another quadratic equation. This one does have an x term, so I cannot do square root method, which means I need to set it equal to 0. So let's subtract the 14. That'll give us 0 on the right. Combine like terms. Negative 6 minus 14 is negative 20. And factor if we can. So, do we have factors of 20 that subtract to be 1? We do. We have 4 and 5. Different signs, larger positive. So positive 5, negative 4. Set each of those to 0. It's going to give us x equals 4 and x equals negative 5. So let's check the 4 first. 4 plus 3 is positive, and 4 minus 2 is positive. So 4 is good. Then let's try the negative 5. If we put negative 5 here for x, negative 5 plus 3 is negative 2. I can't take log of negative 2, so we're not going to use that answer. Just x equals 4. Okay, we'll do one more of this kind. And remember, the reason we're able to do it this way is because every term is a log term. Look at number 3. Log, 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 log. We don't have any constants here. If you don't have any constants, you don't have to do the convert to exponential form step. And that's the step that normally causes students a hard time. So We need each side to be a single log. We have a minus in between, so when we condense, we're going to divide, and that is property 6. So the left side, we still use ln. The x minus 5 has to be on the top, and with the x plus 4 on the bottom. And on the right side, basically same thing. We've got minus, so we condense to one log, the x minus 1 on top, the x plus 2 on bottom. Okay, so now we have our single logs. We have ones in front. We can set m equal to n. So x minus 5 over x plus 4 equals x minus 1 over x plus 2. So here we have a rational equation again. We had one just a moment ago, and we talked about, okay, the method is to multiply by the LCD to clear out the fractions. So here the LCD would be the product of the two denominators, x plus 4 times x plus 2. So we'll go ahead and write that next to each term. And then on the left, we can divide out the x plus 4's. So that leaves me x plus 2 times x minus 5. And on the right, we can divide out the x plus 2's. So now I've got x minus 1 times x plus 4. Now notice that's the same thing we would get if we cross multiplied. We could do these two, x minus 5 times x plus 2, and then equals and multiply these two. If there's one fraction on each side of the equal sign, you can do it that way. You can cross multiply if you prefer. Okay, back to the left side here. Let's FOIL that. It's going to be x squared minus 5x plus 2x minus 10. And on the right side, x squared plus 4x minus 1x minus 4. Combine like terms. And we do have an x squared in our equation, which makes it quadratic. However, since it's the same coefficient on both sides, if we were to just subtract x squared, we wouldn't even have that term anymore. It would just turn into a linear equation. So since it's linear, then I just want x's on one side, constants on the other. So I'm going to subtract this 3x and add the 10. So now I have negative 6x equals 6. Divide by negative 6 gives us x equals negative 1. Alright, so let's take negative 1 and plug it in for x in our original. So we'd have negative 1 minus 5 there, which would be negative 6. We cannot take the log of negative 6. So we're going to go ahead and mark that out. We don't have a second solution, so if that one doesn't work, we would answer no solution. Okay. That brings us to the end of our examples. There are several homework problems for you to use to practice to really get the hang of this. And probably you want to go ahead and put the steps for all the different equations that are in 4.4 in your notes. Generally, I see students miss problems out of 4.4 the most on this next test coming up. So make sure you really practice those steps. Write them down to bring to the test if you need to, and we will be back in class for those of you who come to that 11 o'clock class to work on this then, if you guys need some help. If you're not in class, then you can email me if you need help on these.